To balance a redox reaction in an acidic solution, first you're going to need to have the reaction given to you. So this equation is a redox reaction because iO3- turns into I-. So the oxidation number of I in the reactants is +5 because oxygen is always -2. So since there are 3 of them, it's going to be -6. Since the whole compound has a charge of -1, then I must be +5. And then in the products, I is -1. So we know that iodine changes charges, so it's going to be a redox reaction. And the same is the case for Mn. It changes from 2+ to 4+. So a trick to remembering this is Leo and Gur. So Leo means losing electrons oxidation, and Gur means gaining electrons reduction. So since it goes from +5 to -1, it's becoming more negatives, so it's reducing. And the opposite is true for the oxidation reaction. So the first step you need to do is put it into half reactions. And you can do this by just knowing that I would change into I-, so you put that in the same half reaction. So in this case, you have 3 oxygen in the iO3-. So you have to add on the other side of the equation 3 H2O because you need 3 oxygen on the other side. And in response to adding the H2O, you need to add the 6H+ because there's 6 hydrogen on the other side now. Now, when you have a balanced reaction, it's not just balanced by how many elements are on each side, but the charges on those two. So the whole left side of the equation without the electrons is 5+, and the whole on the other side is 1-. So you have to add 6 electrons to the left side in order for the charges to be balanced. For the Mn2+ equation, you need to write out what it's given to you, and then do the same thing. So you have 2 waters on the left side and 4 hydrogen on the next side, and then 2 electrons because you need to balance the charges. So then we run into the case where we need to make sure that the electrons are balanced in order to cancel them out and have our net ionic equation. So what you need to do is multiply the entire equation by 3. This will allow us to cancel out all of the electrons and therefore add the equations to get our final net ionic. So our next step is to combine the equations. So you add the equations next to each other. I usually line up the arrows over here so that I'm able to see where what side of the equation is. And so you see here that we have the 2 equations that we wrote out, and I distributed this 3 throughout the whole problem, not just to the electrons. So when you multiply the 3 out, you get 6 water plus 3 Mn2+, and that yields 3 MnO2 solid plus 12 H+ plus 6 E-. And like I wrote up here, the electrons need to cancel in order for us to make the net ionic equation. So that's why we multiplied the whole equation by 3. So when you add the equations, essentially you just have to subtract them like you're doing elimination or substitution in algebra. And you end up getting iO3- plus 3 H2O because you have 3 H2O on this side and 6 on this side. So you end up with 3 on this side. And then you get plus 3 Mn2+ yields I- plus 6 H+ plus 3 MnO2. So that's our final net ionic equation. A few things that are important to remember are you can check using regular balancing techniques. Like I said earlier, you need to know the number of elements on each side have to match, just like normal balancing. So you have to check there's the same amount of hydrogen on this side as on this side, and Mn, and also with oxygen and any element that's there. So you also have to make sure that the charges on each side match. So if you did this whole process right, then it should be correct. And just one side note is don't forget states, especially in your final answer, because they oftentimes check for those, and it's usually a point.